Welcome everyone. My name is Julian and this is James. We are the people who've been working on Radicle, the language we'll mostly be talking about. But in addition to Radicle, we'll also be talking about the open source coin project in general, its motivation, and how Radicle came out of that as the answer to some set of constraints. Now, the starting point of the path that led to open source coin was thinking about how Bitcoin has a system for decentralized value creation and distribution. Now, what I mean by this is specifically mining. When you mine, you're as a miner, you're contributing to making the blockchain, the Bitcoin blockchain, function, so that transactions can be received, so that security is preserved. And as a reward for that, you get some number of coins. But the system happens in an entirely decentralized way. There's no sort of central bank or company that's allotting the value created to the people creating it. Now, this is sometimes called inflation funding. Now, let's think about the people who are being paid with these newly mined coins. Now, in Bitcoin, the story is the network operators, the miners, the people who keep the infrastructure going. Now, this kind of makes sense if you think about it. It's the people are contributing value, are making the currency be valuable, so they should partake in that value. But other people have started realizing that it's not just the miners who are responsible for creating that value, but a number of other people as well. In particular, the most obvious example is the developers who create the protocol, the developers who improve it, who fix security bugs, but also researchers perhaps who write the papers that eventually make it into the protocol, technical writers who might write documentation and make the system more popular and more widely known, designers who maybe design web browser interfaces or GUIs that allow you to interact with these systems. So in addition to rewarding network operators, if you're going to reward people who are giving the system value, for giving it value, we should also reward this human work. And this is what Bash and Zcash and Schema in their own different ways are doing. They might have a centralized treasury, for instance, that receives some portion of the newly mined coins and distribute it according to some consensus or whatever decision-making procedure there is to these people. But still, the range of people who are benefiting from this is fairly limited, namely the people who are directly working on the protocol. Now, if you think about platforms like Facebook on GitHub, we often hear it said, and I think that it's kind of obviously true, that a lot of the value in these platforms comes from the people who use it, the users, but they're not directly rewarded for it. So we can perhaps imagine a bigger platform that rewards its users as well. From that perspective, in one particular application of that idea, we should go from funding protocol-related work, possibly to funding any type of open source-related work, as in the case of GitHub. First, we have a very serious problem, which is open source developers are so crucial to the functioning of most of the technology that we use, but aren't usually rewarded very much or very often. And so if we can solve this problem, that'd be great. But if you look at GitHub, the reason why it's worth something, worth as much as $7 billion, is because of the importance of these users who have repositories and maybe who are participating in the marketplace. And if we extend this a little bit more, if there's more sort of transactions happening in the system, such as, for instance, bounties, then the value of the currency that allows you to put out these bounties is dependent on what those bounties can do, who's involved in the platform, that you can pay a bounty or reward with a bounty. Additionally, maybe They're different. We particularly don't focus so much on bounties, but a staking mechanism where perhaps you can indicate that you believe in a project and thereby sort of show that it has meaning to you. Or perhaps you do it not for altruistic reasons, but because by so staking, you get some say in the direction of the project, what issues are prioritized, for instance. That currency gives you that power, but that power is only meaningful because there are projects on your platform. So we should reward that. We should bring open source developers into a platform that rewards them from being, directly rewards them for being there. So let's create an open source network, right? What I mean by this is something like an alternative to GitHub, GitLab, or Bitbucket that is decentralized architecturally, meaning that it's not the servers that GitHub owns that do all of the work, but instead something more like a blockchain where we can collectively, communally decide, own the system and decide how it operates, and also economically decentralized. So it's not just GitHub who's deciding how to allocate value, which usually means not giving it to you, but to everyone. Now, if you think about this, once you start trying to move from the idea towards the implementation, we start to notice that this has a lot of components. That something like GitHub has a lot of components. There's the code, so there are millions of repositories. Those codes have various issues. Those issues have various comments, various PRs, various rules about who's an administrator and who is a collaborator, who can read and who can write. But additionally, we're adding value exchange and possibly other things. We have to address all of these, and that's quite a lot. Now, additionally, now that we have the ownership of the platform in this system that we're envisioning, we should also be allowed to change it. When GitHub, when there's a feature in GitHub that you want, you're mostly not going to get it. You can ask for it and wait for a long time, and maybe if they decide that it's valuable to the people who are directly paying, they'll implement it, maybe not. And sometimes those features, if you could do it yourself, are quite simple. This sometimes leads people to code hosting. There are various reasons why you might want to do this, but hosting your own sort of GitLab servers so that you can control them and you can program them to your liking. But that's a fairly heavy-handed system that takes you out of a network. Right? So we want each of these things to be programmable. Again, now we have the right to program them because they're ours to collectively own rather than GitHub's. And so given that, we might as well give ourselves not just the right, but the means to do it. But again, let's think a little bit more about what that means from a technical perspective. Bitcoin and Ethereum and most chains, most blockchains have a single chain, a program that contains everything and is capable of everything. When you think about millions of repositories with hundreds, thousands of commits, in addition to everything else, that doesn't look very good. We don't want everyone to be having to deal with all that data. There's so many services, so many components to the service that GitHub provides, that if everyone who is using the system is syncing the entire chain and validating the entire chain and running the entire chain that contains all of this, they'll become very quickly infeasible. So instead, there's a push from this perspective to make interest selective, interest in particular parts of the system selective. Additionally, in what I mentioned before, there were various components to the service that GitHub, for instance, provides. Again, PRs, issues, code itself, and those separate out semantically quite cleanly. What I mean by that is there's a number of what might be called threads that in these threads only certain things are allowed, and what those things are mean something different based on what thread they're located. if I make a comment in an issue that's different than in a PR, it's just the context is different. But also if you're seeing the set of commits to a repo as a chain, there are only certain things are allowed. It has to be a valid patch. It has to apply cleanly to your previous state, otherwise it's meaningless. And if you try to just write a comment, a normal arbitrary string, that doesn't make any sense in that context. So these things have their own semantics. Additionally, there's also something like rights to each of these shapes, right? Like in code, in a code repository, only certain people are allowed to write to it. So this leads us to the idea of, from multiple threads, different purposes, multiple chains, different semantics. Commit chains only allow commits or patches. Voting chains only allow votes. Comment chains allow text. Now, with this broader view, I'll let James sort of dig in a little bit deeper into Radicle more specifically.
Thanks. So, June has talked a bit about the background and the requirements that are needed for this language. And I just want to talk a bit more about how that translates into the rationale behind the design choices that we've made with Radicle. So the point I want to make here is that blockchains are essentially replicated state machines, RSMs. And that's because the really valuable component of a blockchain is the state that it holds and the inputs that arrive and how those inputs affect the state. And the amazing fact that because of the consensus algorithms, we can all agree on what that state is eventually. So he talked about how in our use case, it doesn't really make sense to have the whole application running on one blockchain, but we need to split it up into a multiplicity of chains. So what we've decided is that instead of having the model where we've got one huge RSM that is simulating a bunch of small state machines, we're going to have a multiplicity of state machines. So we need an easy language to keep defining over and over again all of these state machines. And that's the goal of Radicle. So we thought, well, instead of, because we want to have a uniform way of doing it, so instead of defining in an ad hoc way a state machine each time, we would basically just instantiate a single state machine, which we understand every single time. But we give that state machine a very specific power, which is that it can simulate any other state machine. Now, of course, that needs to be given with a configuration, so that's a piece of data which will tell the RSM what state machine it's meant to be simulating. And the other very interesting property that we looked at was, what if an RSM, once it was deployed, could not only have an arbitrary behavior that's set at the start of its life, but that during its life cycle, it could also change and start simulating another state machine. In that case, the change of state, the update, if you will, would be governed by the consensus that's already on the chain, and also governed by the semantics that are currently running on the chain. So for example, if the chain has a voting procedure to enact changes, then that change would be governed by that. And also you would keep the state. Keeping the state when you update a chain is always really hard, especially when you're forking. So we decided that what we needed was a language or a DSL for defining replicated state machines that can become any other replicated state machine in response to certain inputs. So as an example of this, let's look at a really important security library. And they have a Git repository that they want to manage. So they will start up a chain, and that chain, as its state, will just have the Git repository and some other metadata involved with the governing of what happens onto that repository. So for example, who is allowed to make commits, who is allowed to create issues, etc. And this is such a high value piece of code that there are a few admins, and only these people are allowed to decide who gets to merge code and when, and also other important things. And the life of this repository moves on a bit, and after a while, the management process becomes too cumbersome. So maybe the whole population of the participants decide that they need a new voting process. Maybe, for example, they decide that current admins should always be given veto rights on who should become an admin. Or they decide that only current contributors can be made into admins, etc. So since the voting procedure is already baked into the chain, how can they change that? So if we assume that whatever is going to change that, let's start with how this behavior is already coded. So if we have a language that's specifying the behavior of the state machine, presumably there's a function vote somewhere in the code that is collecting and counting the votes and checking that each person who tried to vote is indeed allowed to vote, etc. If we want to change the behavior of this function, and we want that change to be a normal input to the state machine, then we have to consider these sorts of inputs, which is a piece of JSON, which contain in the input code for a new version of vote. So this is going to be tricky because the code for the new version of vote is presumably going to be a string. It needs to be passed. We need to know exactly what the executable that is passing it is doing, etc. So Radicle should be a language in which this is a very natural thing to do. So it should be a language that can code a state machine that receives source code in Radicle and can easily manipulate that source code and possibly interpret into something else. So when you think about this, this leads very naturally to the idea of a Lisp. Because in a Lisp, code equals data, which is homoiconicity. And that means that all of the code of the language is represented in the basic and fundamental data structures of the language itself. So then, by definition, manipulating, transforming, and eventually interpreting code is just like any other programming task, and so easy and natural. Lisps are also high level, which is great because that means that someone can spin off a sidechain very easily with just a few lines of code. And it also has a very small core of primitive forms and functions. And when you combine these two properties together, that also means that Lisp has the really amazing property of being able to interpret itself in just a few dozen lines of code. And that's great because if you need to interpret code that's coming in as inputs, then maybe you want to interpret it in a special way. Maybe you want a very safe interpreter that can't do certain things, or you want to charge people for executing code on your chain, so you want to count all the cycles, etc. If you want to do that, that's fine. Just write your interpreter. So what we arrived at was that we take a language that is Lisp-like, and we code up an interpreter, and that interpreter itself is our replicated state machine. Its state is the environment, the inputs to the interpreter are the inputs, the outputs the outputs, and the transition function of the state machine is the evaluation function of Radicle itself. So to conclude, we have a Lisp, which has the really rather remarkable ability that it can define in itself its own evaluation function. Now if we go back to that piece of input which had to change the behavior of the voting function, it now becomes a piece of Radicle, which is just a Radicle data structure, which has a nested piece of Radicle data structure, which will be the code for the new version of vote. And instantiating that new function just becomes a call to eval. We take the code, put it into eval, now you have a function. So we've got a Lisp which can redefine its own evaluation. That's the conclusion that we arrived to. And a few other properties. It should be a language which is deterministic because it's going to be running on a chain, and we need consensus, so everyone should agree exactly what's going on, and if different versions of the program running on different computers are doing different things, we can never do that. And it should be side effect free because everything should be safe. Another point about redefining eval is that if you think about a chain and a chain which has specific semantics, then it shouldn't be able to accept arbitrary inputs because some of the inputs might be invalid according to the semantics of the chain. By redefining eval, we can easily reject any input that we don't like and therefore keep the semantics of the chain intact. And the other big decision that we made was that, at least by default, all of the values manipulated in the programming language should be immutable. And the reason for that is that there's going to be a lot of code which is going to be proposed, some of it accepted, and the coder and the people reviewing this code should be comfortable reasoning about the code locally, i.e. just that piece of code. And if you've got values which can be mutated in various ways, then that's very hard to do. And now we're going to try and demo some of these features, and I hope that you will understand why a Lisp that can redefine its own eval is good. Gonna go to the website?
Yeah, if I can.
So we're trying to get to a website which has the Radicle REPL running.
So this is radicle.xyz. You can all try it out. The Radicle interpreter was written in Haskell, but we've also compiled it to JavaScript, and it's running here so that you can use it easily without having to install all the libraries. That said, there are some corner cases that compilation of JavaScript sort of messes up. So consider this sort of alpha. Now, as we mentioned, this is Radicle is a Lisp, and in that sense, it has prefix parenthesized notation for function application. So addition is it's sort of unfortunate that it's exactly where the plus 3, 2 is the way in which I described 3 plus 2. Now, as you might notice, there's a dot after that 5. There's currently only one numeric type. Now, we also have a few other data types. The most obvious is Booleans. We have true and false. They have the traditional scheme syntax for and so if I write if t high, otherwise by, I get the expected result. Now, additionally, as mentioned, the language is immutable by default. So if I define a dictionary, a map, with two keys, key 1 being 1 and key 2 being 2, these, by the way, are keywords, as you have in Clojure. Now, if I look at the dict, it's as I expected. If I insert a new key so as to overwrite it, the value returned is in fact 0 instead of 1, but a dict is still the old value. I'll make it a little bit bigger again.
You can just type, I think.
What?
If you just type, it will correct this.
Really?
Yeah.
Now, there are, of course, lambdas and functions. I can define an increment function that takes a value and returns that value plus 1. There are also, of course, for functional programming language or for Lisp, there are also, of course, higher order functions that take functions as arguments. So this one, for instance, takes a function and a value and applies that function twice to that value. And if I apply twice inc to 0, I get in fact 2. In addition, to demonstrate, again, this is a normal feature of Lisp, but to demonstrate coding and evaluation, this idea that code and data are very similar, if I define foo to be not 1 plus 2, but instead the coded version of 1 plus 2, I can see foo is not 3, but instead the code that would evaluate is 3. And in fact, if I try evaluating it, it's 3. But I can also manipulate it. I can look at the tail. It's a list, so I can look at the tail of it, and it's just those two last values. I can define bar to be cons of the coded version of minus and the tail of foo. And if I look at bar, it has a minus instead of a plus, and if I eval bar, it's in fact the value that I'd expect. And this again is as you would expect from a Lisp. But if you look at, again, if I do 3 plus 2, nothing surprising, this is the first line of the code. However, I can also redefine evaluation, in this case to a very silly thing, a function that takes any expression and returns just true. Now, if I try the same thing, I get true, because the semantics of the language has changed. In fact, if I try anything else, I'll get true. Now James is going to talk about some more interesting applications of this language.
Just a quick question. Were questions at the end?
There will be questions at the end, but if you...
Yeah.
Are you compatible to any standard library, or do you have to implement that from the end?
So, because of the restrictions like no effects and immutable values, there is no current scheme, I think, that would be applicable. But we are currently basing the syntax on closure.
This closure would be, yeah.
Yeah. So that was a redefinition of eval, which was really very trivial. And now we're going to try and redefine eval on a remote chain for an interesting example.
Wait,
Okay.
sorry, did you just say that you're going to stick to the syntax of closure?
Yeah.
Large.
Well, maybe. Maybe.
Do you want to go in front so you can see this, or I don't know?
Sorry?
Can you see what I'm typing?
Yeah.
No.
Okay, so right now he's set up the REPL, and we're going to send the prelude. Prelude is a piece of code which is like our core libraries and our core functions. And he's going to send the prelude to an address called rad, which is the address for a remote chain.
And just to explain what we're doing, here, so I'm creating a chain that will be the issue chain, a sort of toy issue chain, for the radical prelude itself. So I'm going to create a chain, and that's going to hold all the issues, and it's going to have a special feature.
Yeah, so send prelude will send all of the prelude code.
And there's one more thing I want to say. So we mentioned that so this language is pure, and that's true of the language as it runs on the chain. As a convenience, we've also exposed an impure environment that you can run in your REPL. So we've maintained that distinction, and there's no way of running impure code on the chain, but there is of running impure code on your REPL. And usually those functions that are impure are distinguished textually from the others by an exclamation mark. So we know, in this case, we're sending something to over the internet to a chain somewhere.
So we send the prelude, and now we're going to send the code, which contains the new evaluation function that we want to be running on this chain.
Look at that?
Yeah.
All right, I'll send it, and then we'll look at it. Yeah, send code.
So send code doesn't send values, it sends just the text files, and then they will be evaluated on the remote chain.
Let's look at
As long as the remote chain still has that semantics. If we look at the code for this, rad issue chain eval is a lambda which takes an expression and then does something to it. The point of the chain is to maintain a list of issues with the radical prelude itself. So the particularity of this chain is that when someone submits a new issue, it'll check that the issue has a failing test case. So the message that someone has to send has to have radical code itself that represents a test case, and that test case will be evaluated on the chain. So if it fails, the input will just simply be rejected. And this means that we can maintain a list of we can maintain a list of issues that we know are failing. And this is great. If you're a maintainer of an open source repository, then you might get a whole bunch of issues being submitted. Some of them, well, most of them will not have failing test cases. Some of them will have failing test cases, but in fact, it's already fixed on master, or there's a typo in them. The semantics of this chain do all of that automatically. It will automatically curate the list of issues for us.
So someone who wants to create a new issue has to submit a failing test case that's in fact failing. Additionally, that's just a piece of code. So if we wanted to write a little bit of code that takes the failing issue and puts it in our test suite, and maybe runs all of it when we submit a new PR, we can do that automatically.
So we send this code, that's already sent. And now we send a message which asks the remote chain, which is already just with the default eval.
Wait,
Oh, you want to do a remote chain?
yeah, right?
Okay. So we're going to use another function that we have locally, which is called enter remote chain.
Wait, I'll first send the, sorry, I'll first send the
Okay.
So, so now defining eval on the chain, right? So this is being sent to the chain, and I'm defining it to be the eval that I've written in a library that I sent to the chain, and therefore the chain knows how to evaluate it.
And now we'll enter remote chain. So enter remote chain is a function which takes the address of a chain and another thing. And what it'll do is it'll go to the remote chain, take all of the inputs of that chain, catch up a local version of it, and allow you to submit inputs. So our REPL has now become the remote chain. It'll then store all the inputs that you're submitting locally, so you can experiment with what would happen on the chain. And then if you're happy with that, you can then send them back to the chain. So we've already defined eval to be the route issues thing. So now we can list the...
If you try doing something else, it won't work. An error because eval has been redefined as it was in the browser.
And if we list the issues, we'll get none because it's a new one. And we can define a new one. So I'll add an issue which says that everything's fine, that 0 should be equals to 0. And because that's already true, I'll be told by the chain that it's not a failing test case, and so I can't add the issue. Julian will now add another issue where he will impose that 1 should actually be equals to 0, because he's not very good at arithmetic, and this will be accepted because 1 is not equal to 0.
So in theory, at least, it looks like a bug.
So it's a failing test case, and now if we list the issues again, we'll see that it's been added.
Shall I make this bigger, by the way? I'll make it a little bigger.
But it's only been added locally. So now what we can do, because we're happy with the results, is send them up to the chain. That's done. And just to see that that all happens well, let's enter the remote chain again. And we can see that it's now synced to a higher index, and that the issue is there. Right? Okay, so that's enter remote chain. Now we're going to do an even more involved example. So this example set up a new chain and had an eval which set up a specific semantics. But it didn't change the semantics during the life cycle of the chain. So we're going to do another example where now it's a pull request, and the thread allows adding new comments about the code under review. I'm going to make it a little smaller. Okay. So this time we're going to define eval using a library function called state machine eval, which is something we've already got defined, and it's a higher order function which takes a hard-coded list of voters, an initial state, and an initial transition function. Now note that I said initial transition function. This transition function will change throughout the life cycle of the chain. Voters is a hard-coded list of people who will be able to vote on proposed new transition functions. So at a high level, the chain only has 4 basic inputs. Inputs, and then another argument, are the normal inputs to the state machine. New transition function is a command to propose a new transition function to the chain and ask for the voters to agree or disagree on it. And then you've got agree and disagree for voting on that proposition. So let's go to the code for state machine agree. Yeah. So here we have, some basic logic. If the person voting is part of the voters, then do some stuff. And the stuff that we're doing here is we're extracting the function from the state that's been proposed, and then we're evaluating it if the vote is now finished. And once we've evaled it, we'll instantiate it as the new transition function. So let's see that in action. So we'll start a new chain by sending the radical prelude to it. And the current prelude already has all the code for the state machine. So now we can just define eval in that chain to be PR thread. And now issue 54 is the address of a chain, which is our pull request. So we can start sending inputs to it. Oh yeah. So Dream will send a few inputs, which are comments about the code. And note that this state machine transition function, the usual inputs are lists of length 2, where the first item is the username of the person who's making the comment, and the second item is the comment itself. No working?
Yeah, working.
Oh. And here we have a React front end that is connecting to the API, which is automatically exposed for all chains. And all it does is it gets all of the outputs of the chain, it JSONifies it, and then you've got a little React app that can display them nicely. So that's the first comment. So you want to add another one?
Yeah, so
Cool. Okay.
then update it again.
So now what we're going to do is Julian is going to decide, because it's his code, that he actually wants to update the semantics of the chain. So he's going to propose a new voting function, or a new transition function. So he's going to start writing that down. So it's going to be a function which deals with comments from a particular user. So it takes the state, the current state of the chain, or of the state machine in the chain, and an input, and then it checks if the input is of a particular format, and if it is, it treats it one way. And if it isn't of that particular format that he's looking for, he will just call the original transition function. So he saves that to a file, but note that he hasn't actually created a lambda, he's created a quoted form, which means that the value that he's created is just code for a lambda. So we can load that file up. Now that variable is in scope, but it's just code. So with that code, you can then evaluate it locally just to test it out. So because there's code for a lambda, if you evaluate it, presumably it will create a function. So now Kim comment function is a function, and so we can call it. We're going to give it some dummy states, which is the next ID for a comment, and the dummy input. And we'll see if it works.
Is that enough practice?
Yeah. So it's given us the new state that it would produce and the new output, the output that it would produce as well. So we're happy with that. So now he's going to submit a command to the chain according to the chain semantics, which proposes this function as the new transition function.
So Kim comment is being evaluated in my local environment, and so being resolved to what it is where I know it, as I know it here.
I.e. the code for the function. That's been sent to the chain.
You can see the proposal over here.
Yeah, so now everyone else who's participating in this chain can see the code of his function, and voting can begin. There's only 2 hard-coded voters, Alice and Bob. So we'll just push their votes through. And now it says that the new function that was proposed has taken effect. So now we've got a few more comments. So most of the behavior of the chain hasn't changed, but if Kim makes a comment, then
Let's scroll it down.
how do I scroll it down?
Yeah.
There we go. So what's happened here is that the chain had a semantics in place for updating itself using a voting mechanism. And with everything and everyone being in agreement and the consensus mechanism happening, that behavior was changed and the chain was updated. Yeah, so that's it. And we really hope that you try out Radicle on radicle.xyz, submit bug reports.
They'll all be rewritten to this is great. Yeah, and there's a lot more that we have been doing and want to do with Radicle, and there are also a number of other components that are beginning to fit together in open source Coin as a whole. So, for instance, we now are developing CLI apps that allow you to sort of integrate with the system as you would in a fairly well-known and familiar way, and eventually, hopefully, get remote helpers as well, so that you never have to, via normal Git commands, it always seems like you're using the system that you know, and in fact you are, but it's integrated with Radicle, our chains, and the open source network generally. Yeah?
I can't believe that works, but yeah. Thanks a lot.
Yeah, of course, if there are any questions, please.
Just curious, so an example for the remote chain that you guys are using for examples, where was that remote chain being synced by multiple nodes, or was it a single node that was hosting the state machine?
So I'm going to repeat all the questions because of the mics. So the question is, were the examples that we were using, were they being synced to multiple nodes or just one machine? And in this demo, it was just one machine. I think now we have integration with our own consensus, but for the demo, we used just a centralized server. From the perspective of Radicle itself, it's very easy to change between those. So the semantics is 95% the same.
Just follow up. So Radicle is purely for defining the semantics of the state machine, and then the components that help you deal with like networking and consensus are like completely separate, and you kind of just combine those together for building out the actual chain. But the language itself is just for defining the semantics.
Right. So yeah. So if I'll rephrase it and tell me if I got it wrong. So is Radicle itself only for the semantics of the chains and maybe interacting with those chains, but not about building consensus itself? Yes is the basic answer. So we have primops called send and receive that currently in this code are pointing to centralized servers, and there is no logic besides sort of sending and receiving. There's no logic within Radicle about consensus. You just point them at something that, approximately, you just point them at something that is that partakes in consensus. And then, so this is the REPL. It's running locally, and Radicle is also running inside the consensus system. It's running in the server that we're using, but it also runs inside consensus, which decides whether, in fact, an expression that you send, a transaction, as it might be called in other in other blockchains is valid. Now, the story will become a little bit more complicated in the sense that, or not complicated, nuanced, in the sense that there will be certain things that are more related to consensus that will have to surface in Radicle. But roughly, that is the sort of separation, right? It runs on, it is the language that our consensus engine starts off with, and it is the language in which you interface with the consensus machinery, but it's not actually, the consensus is not built on it, but lies underneath or onto the side. I don't know if that answered the question.
Yeah.
But I think there'll definitely be primobs which are related to that. For example, a primob to decide what is the key of the person who submitted an input, etc. Because that needs to be often resolved during the evaluation of the input itself.
Anyone else?
I'm just curious. So,
Yeah.
like for the example code that you wrote that you sent to the remote chain, you had, like in the first example, you had like new issue. Oh, let's just take new issue, for example. Would it be an accurate mental model to say that on the remote chain, that new issue becomes like a trend? Like if you're talking about traditional blockchains, like that new issue is like a transaction type?
Yeah.
Is that accurate to say?
Yeah. So yeah. Yeah.
So any input which is accepted by the redefined eval is a transaction.
Yeah.
You guys want to try to put this in a more traditional blockchain context? I assume that most of the people here are aware of the Ethereum, for example.
Yeah.
Like, can you talk about the analogy with that or with Tezos or with all those other things?
Yeah. So one important thing, one thing to say is that we haven't sort of made this explicit, but Tezos is relevant. So Tezos has this sort of introduced this system for on-chain governance, right? And the way in which it works is like sort of like not, it's on-chain in some way, in some sense, it's in the blockchain, but we're and you can change the semantics of the chain by agreeing to it, by having some sort of process that determines when a new binary essentially becomes the interpreter for the interpreter or the protocol for your chain. Now, this is sort of making it a much more integrated system, right? In order to change the semantics of the chain, there isn't the sort of like hash that refers to a binary that by convention everyone agrees to, but there's in fact one sort of interpreter or one abstract interpreter. It doesn't have to be the one that we've written, but one that follows the to-be-written spec. That from there you don't really, like it's an integrated system updating and on-chain governance. As we saw, on-chain governance was very, very simple here. And we imagine this being used so frequently in chains, in the context of Ethereum or Bitcoin or Tezos, any decision to change the semantics of the chain is a huge one, and it should be a huge one because it affects everyone, and there's a lot of money at stake. And so there's this long-winded process, and it's not very convenient, and that's okay because it doesn't have to be convenient because it doesn't happen all that often. Tezos makes it a little bit simpler, but when you see Ethereum and Bitcoin, there's this huge effort to make sure that all the miners agree at the block height in which some new piece of code or some new feature is going to be added or removed. Now, in our context, there's so many chains that have a very limited scope. Only maybe like five or 10 people are interested in what's happening. And if we had to wait for a sort of release of a new binary in order to have a change into semantics, which no one would agree with, because again, why would you change the binary for 5 or 10 people? We'd essentially be stuck in the sort of GitHub situation where a lot of people are using the sort of software and they want some feature, but they can't get it. And so this is a much more sort of integrated and nuanced form of on-chain governance than you might see in Tezos. And as a sort of related to sort of Ethereum, as you might have sort of noticed, there are multiple chains. Not all of them are necessarily blockchains. There might be permissioned ones. In fact, there will be a lot of permissioned ones. But if Ethereum sort of introduces this idea that the language in a chain should be general purpose, that is, the chain should be programmable, you can program in the chain. We actually make the chain programmable itself, right? The chain is you can program what the chain does rather than just program in the chain. So that's sort of like sort of I don't know if that. Oh, and by the way, the question was, can I compare this to Ethereum, Tezos, and Bitcoin? I don't know if that's.
How are you guys funded?
How are we funded? So.
I can answer. We did a seed round back in December with a few people. The one is Blue Yard here in Berlin. The other one is placeholder, Chris Control Monaco, and then Brad Vernon. And there's some invested in a few other people basically in that investing. And then, and it's a very small thing. We want to bring this live with coding and building for a year already now. And then from now on, we're moving from the space of just like researching and coding to starting releasing stuff, and that's the first thing that we're going to be releasing. And we're aiming to be in a testnet around Q1. We'll see how close we're going to be. Not at this stage, but we're not looking to raise money right now, but we're still.
I'm not gonna repeat the entire answer because I don't think I can.
So for these, if you have these separate chains for various functionalities, like let's say issues or PRs, how do you envision the user experience for, like traditionally, if I'm like an open source contributor, just hop onto GitHub and use it, I don't worry about anything else from an infrastructure standpoint. How do you envision users engaging with it, and like who the node operators are to like sync up that chain?
So that's actually sort of a
Question.
Huh?
Repeat the
question. So the question was how do I envision users, or how do we envision users interacting with issues, with PRs, and all these things? It's a fairly simple and well-known and familiar method with GitHub, and now we have all these multiple chains, and what's the story there? So part of the answer are these. So that's a sort of, for us, very crucial component actually. We want it to be the case that people move into the system, even if they're not that interested in decentralization, because the tooling is better. Now that's a big ask, and so right now we're focusing on the terminal tooling, right? So the idea is, if you have a system like this running in the background, you can have a CLI that's talking to that system and pulls up all the chains that you're aware of or interested in, all the PRs that are open that you haven't seen yet. And so the idea is somewhat, part of the answer is that actually, despite all this freedom, we're going to also have sort of standards. The community hopefully will come to an agreement upon standards about how issues operate and how they're structured, so that tooling can engage with those in a somewhat uniform way. And then tooling can sort of, just as we're syncing with remote chains, quite simply on the REPL, a command line tool can be like, okay, like every time I start up, just pull all of the issue chains that I'm aware of, look at what I haven't actually already marked as read, or all the PR comments. Actually, the revision tooling in particular, which Alexei, Tomasz, and I think Thomas maybe as well is working on. That is going to be a much sort of more, and Julien, who's been designing a lot of the design that we've spent on, the design time that we've invested has been precisely in that sort of tooling, and that's going to be something that needs its own talk.
But we are hoping that it provides a very familiar interface to these chains.
But mostly for now, at least. Aside from, so of course, using a browser is, like, as we've shown, very easy if the outputs of your chain are something that can be easily serialized into JSON, which basically means anything that's not a Lambda. And so this React thing that we have here was an hour, 2 hours, 3 hours to build. So the sort of browser stuff should be easy as well, but we're primarily trying to sort of really pin down the terminal situation, because it seems to me, I'm not sure if this is actually accurate, but it seems to me like the reason why the terminal experience when interacting with GitHub is so bad is because they want you to open the browser and be in their platform, and we kind of don't care. Like, it's like use a terminal because you I don't know, at least for me, so many times using a terminal would be so much easier, but it's not made easy for us, right? So that's the.
I mean, maybe I can add one point on that. it's hard to know how things will play out as we learn. This is a fantastic question, by the way, that we've been discussing a lot internally. I think that probably we're gonna end up something that looks like a bit like a federated GitHub potentially that has also some kind of logical centralization between different communities. But to be seen, you know.
Can you sort of, so fund requests and Gitcoin.
Sorry?
Fund requests.
Yeah.
They're a team out of Belgium. They're also working on the incentivizing open source projects.
Yeah.
I was wondering if you guys knew about the project, you guys talked to them, is it going to work in conjunction?
Note on incentivization. So there are actually a lot of projects that try to go after open source incentivization, and then there's Gitcoin in New York, in Consensus and Eval, Colorado. They do a very good job, but they focus on bounties primarily, built off GitHub. There's Fund Request in Belgium that also try to do bounties on the blockchain, also again of GitHub. Our thesis is very different. So we're going after that infrastructure. We believe that there's value captured by the platforms, by the networks. So we're going after that infrastructure, and then also we believe that by bringing these economic primitives in that infrastructure, not having to rely to another centralized player over here, we can engineer very interesting experiences that they wouldn't be possible to do around the GitHub API. And I can talk a bit about that as well, like if you want, we can grab me after, but we're not just limited on boundaries. We believe that just by bringing code, issues, and value, you can engineer very interesting incentivization models around code, like, you know, Patreon-style models if you want, or bounties, or programmable bounties, or, you know, potentially like, you know, having schemes where you have service agreement to pay your dependencies, for example. So we want to go much further than that, and the only reason for us to do that is to actually go one layer of the infrastructure and innovate there first.
Anyone else? We also have a barbecue party happening momentarily. I hope you all stay for that. And if you want to ask questions, I'll still be around. So like.
Do you want to maybe say what's coming? So there's a paper coming, right?
There's a paper coming. Wait.
Yeah.
What else is coming?
So.
Oh no, you're gonna yeah. No.
The paper is coming, and it will contain a formal spec of this language, because we hope that other people write interpreters, maybe faster interpreters, and we also want the spec to be very nailed down, because if a chain is very long-lived, then it might also be the case that people write faster interpreters for the new semantics of that chain. So we want that to happen as well. So yeah, the paper's coming out.
Website is out.
The website is out. The Radicle website is out. You can use it right now. And if you send to issue 54, then it will appear on this website.
And code base?
So the code base is at git.oscoin.io/radicle. I think it's actually sort of indirectly linked from the website. But the website isn't so confusing that if you don't just press all the buttons, you won't find it.
And be gentle with documentation. We adding it as we're going.
Yeah. We've already sort of integrated a sort of basic rudimentary documentation system for functions, but certainly we need a lot more work on that.
Last question.
Yeah.
Do you have like a community where you can discuss the stuff, like a Telegram group or Discord?
We have the main place for discussions is Radicle in Freenode in IRC. We also, if you say send an email to hello or hi at radicle.xyz, we'll get it. But for sort of more active discussion, I would recommend IRC. Radicle is the channel.
And there's also a Telegram, but usually there it's more like announcements, like engineering talks happening on IRC. Right?
Yeah, sorry, and that's only the Radicle related stuff. There's also an Oscoin channel, OSCoin channel for open source coin in general. There's also a Telegram channel that is mostly for open source coins related stuff.
We should probably distribute a binary soon as well.
Yeah, you can build it yourself from source if you go to git.oscoin.io. As soon as we actually have something that we'll call a release, we will distribute binaries as well. Okay, cool.